A very cold superconductor, a disk, which is a superconductor, and when I put this superconductor, I can't touch it with my fingers, that's why I needed the tweezers, and it just levitates. I don't know if you can see this, but maybe you could help them. It just levitates in free air. Okay? Everyday life, there is always some friction. In everything we do, we lose a certain amount of energy. But not here. In superconductor, they do not lose any of their energy. It's a quantum state of the matter. Now, it turns out that it's not the only thing. And as another physicist, Meissner, discovered, superconductors and magnetic fields have a very unique relationship. And it turns out that superconductors do not like magnetic fields. They try to expel the magnetic field from the inside. And how do they do that? Simply by driving currents inside, because currents do not cost any energy. They are superconductors. So they will create small electromagnets which will cancel the external field. I'm sorry for the technicality. It will soon be over, I promise. Magnetic field lines, strands of magnetic field remain inside this superconductor. And because this is a quantum physical effect, quantum effect, the magnetic field behave like quantum particle, like quantum object. So I'm going to take this superconductor, and now I can lock it. I can force the magnetic field lines inside the material, and it will stay locked. I can rearrange the fluxon. It will stay locked like this, or like this. And it is three-dimensional locking. This is not repulsion. It's not like two magnets. No, nothing like that. Because if I turn this upside down, it just stays. Okay? Forget everything you know about classical physics. This is different. Okay? That's my point to you. Forget everything. If I'm going to take this superconductor, I'm going to lock it inside. Now I get frictionless motion, and it's still levitating, and I can turn it upside down, I can move it, and it rotates without any friction besides the friction of air, of course. The actual superconductor is only half a micron thick, less than a hair, the thickness of a hair, a human hair. And this half a micron thick superconductor levitates more than 70,000 times its own weight. It's a remarkable effect. It's a very strong effect. Why? Because it's quantum physics. It's a new set of intuition. Now, you can see the glow behind the disk. These are just atoms that we throw on the sapphire. It's quite simple. The atoms fall on the sapphire, and they just grow if you have the right recipe. I'm going to take another disk, and I'm going to lock it at a different configuration, and then I'm going to let them spin. Thank you.
Cathode. So in this case, the anode, being the moon, transfers energy towards the sun. Now, since we are dealing with polarity, we can look at the sun and the moon as two opposites. One has an endothermic, means drawing in of heat, and one has an exothermic, which is radiating of heat through chemical reaction. So the moon being cold and the sun being hot, we have a temperature differential. This temperature differential plays into the thermogalvanic cell. The thermogalvanic cell produces energy by this differential in temperature. Again, it moves from anode to cathode, from cold to hot. So we have a gradient of temperature. We also have a differential in voltage and current. So for the anode side, we have a higher voltage and a higher resistance. And for the cathode, we have a higher current and a lower resistance. We also have atmospheric stratification, and this is a layering of different elements at different points from ground to the atmosphere. We also have a pressure gradient, so as you get to sea level, you have a higher pressure. As you go up into the atmosphere, you have a lower pressure. We also have a charge differential, which is lower charge as we get closer to the oceans, and a higher charge as we get into the atmosphere. So as the cathode or sun moves over the oceans, it increases the temperature in the oceans. Now the water, as it heats, expands and allows more salt in. Basically what this does is start to circulate the oceans and bring salts up. And we're also increasing its temperature, increasing its energy, and helping it release these gases from the oceans. The main gas to do with the cathode or sun is chlorine. On the cathode side also there is the production of hydrogen. So it's hydrogen, chlorine and sulfates that are the combination for that positive side. On the negative side we have the cooling of the moon and this condensing effect. So it's acting like a distillation and condensing and refining elements. So on the anode side we have the nitrates, the oxygen and the sulfates. They are the main three. The sulfates are mainly derived from volcanic activity, but also can be found in the oceans. The salt bridge, or earth in this case, is neutral. Through it has the movement of waters and salts, and I've labelled this the ionic flow of aquifers. We also get high amounts of potassium nitrate from these aquifers. The salt bridge in the galvanic cell is where there is positive and negative elements coming together to form neutrality. We also have a type of molten salt bridge, which is to do with magma and lava. I hope you have enjoyed this basic overview